Alright, for this first lesson we're going to do a review and preview of polynomials and polynomial operations. So for this unit we're going to be studying algebraic expressions called polynomials. We review the classification of polynomials, addition and subtraction, multiplication by a monomial, and we're going to introduce the product of two binomials and extend this to the multiplication of polynomials. We'll also be problem solving with polynomial expressions. So to begin with, there's some things that you should already know coming out of junior high. In algebra, a letter that represents one or more numbers is referred to as a variable. Expressions like 2a minus b plus 4 or 5 over x plus 3 are called algebraic expressions, where it's going to be mathematical expressions that include some sort of letter that's going to represent a variable or a number. Certain algebraic expressions are called polynomials based on certain criteria. In order for it to be a monomial, it's a number or variable of the product of numbers and variables. So monomials don't include adding a number or subtracting a number in them. You're basically just multiplying straight across or dividing straight across for one expression. For example, 6x, 6x, negative 1 over 2xy, 0.25x to the power of 3, abc, 2p to the 4, q to the 2 are all considered monomials. The number that multiplies the variable is called the numerical coefficient. So if I take a look here, I can see that I have a numerical coefficient of 6, of negative 1 over 2, of 0.25, and of 2. A polynomial is a monomial or a sum or difference of multiple monomials. So it could just be a monomial like the first two we had, or if I add a plus or minus in between them, then suddenly there's going to be multiple terms or multiple monomials that are being combined, and this can be expressed as a polynomial. In this case, when it says, why is it that 5 over x plus 3 is not a polynomial? Well, we can see up here we said that the exponent must be a positive integer. Well, in this case, if I'm dividing by x, it means that I'm going to wind up having a negative exponent. It doesn't actually balance out. A polynomial consists of one or more terms, which is the monomials we're referring to, which are separated by plus or minus signs. So if it has one term, it's a monomial. If it has two terms separated by a plus or minus, it's a binomial. If it has three terms, then it's going to be a trinomial. And anything above three terms, we just refer to as a polynomial. We don't really distinguish based on the number of terms after 3. So if I'm considering the following algebraic expressions, in each case I need to state whether the expression represents a polynomial or not. If the expression does not represent a polynomial, explain why. And if the expression does represent a polynomial, state what kind of polynomial it is. Well, for the first one, this is a polynomial. Because I can see that it has two terms here, separated by a subtraction, then I'm going to call this a binomial. In the second case, it is not a polynomial. And the reason for that is I have an exponent that is not a positive whole number. The third one is once again a polynomial. And this is made up of 3 terms. This is a trinomial. The fourth one, or D, is not a polynomial. And the reason in this case is because that exponent of 0.2 would just be the fraction of 1 over 5. And the last example is once again not a polynomial. And that's because I'm dividing by a variable. If we move on to example 2, and I'm completing the table, well, the number of variables just means the number of different letters that exist. Here I have an x, a y, and a z. There are 3 different variables. The number of terms, once again, refers to how many different monomials are separated by plus or minuses. And here I have 2 terms. Because it has 2 terms, that's called a binomial. In the second case, I have an A, a B, and a C. I have 3 variables again. I have 1, 2, 3 different terms that are separated by pluses and minuses. So I'd call this a trinomial. In the third case, it just has x. So I only have 1 variable, but it's still separated into 3 distinct terms, and it's a trinomial. In the fourth case, I just have the variable of x. There are no pluses or minuses in here, so there's just the 1 term. So it's a monomial. And in the last case, I have an x and I have a y. So there's 2 different variables. I have 1, 2, 3, 4 terms separated by plus and minuses. And once I get up to 4, I just call it a polynomial. If I'm classifying by degree, then we're talking about degrees. It's the sum of the exponents inside of the variables. So if I look at what exponent is attached to each variable, in this case there's only 1 variable, this would have a degree of 5. In the second case, even though it doesn't list anything for A, I know that if there's an A there, it has an imaginary exponent of 1. So I have 1 plus 3 plus 2. This is going to give me a sum of 6 if I add up all the exponents attached to the different variables. If I'm looking at the degree of a polynomial, then I'm looking for the monomial that has the largest degree inside of here. So here, if I had 2 for the x and 2 for the y, then that means that I have a degree of 4. Here I just have the x, so it has a degree of 4. Here I have x to the 1 and y to the 4. That's going to combine to make 5. And I have no variables in the last one, so that has a degree of 0. The largest degree that shows up in here is the degree of 5. So that is the degree of the polynomial. If a polynomial has a term with a degree of 0 where there is no variable present, we always refer to that term as a constant. This would be my constant here. A constant just means that it only has a number, it doesn't have any variables, and because numbers can't change, it's constant. The value of -2 is always -2. If I had -2x, the value is going to vary depending on what the value of x is in this case. So this one has a constant of -2. For example 3, if I have a binomial, which means I have two terms, it has a degree of 1, and it has one variable, well, there's infinite possibilities that you could come up with here. I could use something like x plus 1, where I need to have at least one variable. I'm not going to state that it's x to the power of 1, but it can be. And I need to have at least one plus in there in order to, or minus, in order to create two separate terms. If I wanted an example of a trinomial with two different variables and a constant, it doesn't say what degree it has to have. So I could say that I could have x plus 2y plus 5. There's my two variables. It's a trinomial because it has three different terms. And there's my constant. An example of a monomial with a degree of 6 and a numerical coefficient of 9 would be if I had 9x to the 6. If I need a binomial with a degree of 8 and each term containing two different variables, well, I could have something along the lines of x to the 7, y, there's my degree of 8, and then I could say that this would be added to 2x, y.